It is time for 9.5. This deals with substitution and elimination of linear systems. So here, it wants us to use substitution. I really don't care what method you use. Whatever method works for you. In this case, substitution is going to be the easiest. So I have y by itself. I'm going to plug that stuff in for y. Negative 3x plus 2 copies of where the y used to be. I replace it with 2x plus 13, and that's equal to 21. So negative 3x, distribute the 2, 4x plus 26 equals 21. So the left side becomes x, and then we will move this to the right side, and I get x is negative 5. And then I can plug that negative 5 into any equation I want. The y equals equation is going to be the fastest. So plug it in there. So y equals 2 times negative 5 plus 13. So 2 times negative 5 is negative 10 plus 13. So y is 3. So my answer, the intersection, would be negative 5, 3. So here you could use substitution, you could use elimination. So I'm going to plug this in there. 7x equals 2x plus 20. Subtract 2x. 5x equals 20. So x is 4. Plug the 4 in there. Y equals 7 times 4. So y is 28. Moving on. All right. I would use elimination here. I want the y's to cancel, and they're both 5y, but one of them needs to be negative, so I will times the top by negative 1. That gives me negative 6x minus 5y equals 10. Then I will add these two equations together. 3x minus 6x is negative 3x. 5y and 5y cancels. And 20 plus 10 is 30. Divide by negative 3. X is negative 10. And I stick that into any equation I want. 3 times negative 10 plus 5y equals 20. So this is going to end up being negative 30. So I will add 30. 5y equals 50. Divide by 5. Y equals 10. Negative 10, 10 is my solution set. Okay. These are a little bit harder. A textbook store sold a combined total of 435 biology and psychology textbooks in a week. The number of biology texts sold was 2 times the number of psychology books sold. So let's call these biology books, and we'll call B, and we'll call the psychology books P. And I know that the total number of books was 435. So the number of biology books plus the number of psychology books is equal to 435. Okay? And I also know that the number of biology books is equal to 2 times the number of psychology books. So biology is 2 times psychology. Now we just do a little substitution. Plug that in there. So B plus, or no, sorry, plug it in there. So 2P plus P is equal to 435. So 3P equals 435. Divide by 3. It's going to give us 145. So P equals 145. And then we can stick that in here to calculate B. So we subtract 145. And I get 210. Oh, sorry. You're right. 190. Do you need to see another one of those? Yeah? Okay. All right, we have a large number and a small number. The sum of the two numbers is 24. So large number plus small number equals 24. One number is the equal sign, 2 times as large as the other. So the large number is equal to 2 times the small number. We plug this in for L. 2s plus s equals 24. So 3s equals 24. So s is 8. And then I can plug s in here. 2 times 8 is 16. So the large number is 16 and the small number is 8. For each ordered pair, determine whether it is a solution to the system of equations. So there are two ways to do this. One would be to plug in every number set to every equation and see if it works. So I'm going to plug 5 in for x and 4 in for y. So 4 equals 3 times 5 plus 6. Is that true? No. So that one's out. That is a no. Okay. Plug -2 in there and 0 in there. Is 0 equal to 3 times -2 plus 6? And the answer is yes. So does that mean it's a solution in both of them? No, we have to check the other side. So I know that -2, 0 hits the top equation. But what I want to know is, does it also hit the bottom equation? So I plug -2, in there, and 0 in there. 4 times -2 minus 7 times 0, is that equal to -8? Well, 4 times -2 is -8, plus 0 equals -8. So this point worked in the top equation and in the bottom equation. So the answer is yes. Okay, let's try another one. 9 goes there and -1 goes there. So is -1 equal to 3 times 9 plus 6? Not even close. So no. I keep doing that. -4, -6. Is -6 equal to 3 times -4 plus 6? Yes. So it works in the top equation. Now we need to test it in the bottom equation. So -6 and -4. 4 times -4 minus 7 times -6. Is that equal to -8? Well, we're going to get negative 16 plus 42. That's not even close to negative 8, so no. That's the slow way to do it. The fast way to do it would just be to solve. And then you'll know which one is the right answer. So we can plug this in here. 4x minus 7 copies of 3x plus 6 is equal to negative 8. So 4x minus, distribute that, 21x, distribute that, minus 42 equals negative 8. So 4x minus 21x is negative 17x. We add the 42, and we get 34. Divide by negative 17, and I know that x is equal to negative 2. Well, that means this one is a no, and this one is a no, and this one is a no. So we plug that negative 2 in for x. Y equals 3 times negative 2 plus 6. That equals 0. So this would be a yes. That's how I would solve it. Just find the answer. All right. I would do elimination here. There really isn't a good way to do it. If I want to cancel the x's, I will times this by negative 3, and I will times this one by 7. And I did that so that the top will become negative 21x plus 24y equals 12. And the bottom will become 21x minus 35y is equal to negative 56. And now my x's will eliminate. And 24 minus 35 is going to be negative 11y is equal to negative 44. Divide by negative 11, and I get y is 4. Plug the 4 back in for y. 3x minus 20 equals negative 8. Add 20. 3x equals 12. So x is 4. All right, we're just about done. Okay. So we have chairs and tables. If I rent 6 chairs and 2 tables, is always the equal sign. It equals $20. So 6C plus 2T equals 20. Also, 3C plus 5T is equal to 35. And then we would just use elimination. Okay. I would do elimination times the bottom by negative 2. Okay. So for system A, I will times the top by negative 1. And that gives me negative 2x minus 3y equals negative 6. And when I do elimination, the x's go away and the y's go away, and I get 0 equals negative 1. When does 0 equal negative 1? Never. So this would be no solution. That means I'm dealing with 2 parallel lines. What if I solve that down and I end up with 0 equals 0? that would mean infinite solutions. Okay? And then here, plug that in there. X equals 6x. So we would subtract x. 0 equals 5x. So x equals 0. And then plug that in here. And we get y equals 0. So this one has a unique solution, and the solution is 0, 0. And that's it. Okay. Get to work.